Hello, good afternoon. Hi, I'm Hamid Abassi, PhD candidate at the Center for Compressor Technology at City St. George's University of London. Welcome to this week Lecture Tuesday. Today, we will be talking about water-injected twin screw compressors, their advantages and challenges. Let's get started. Let me start with the introduction of twin screw compressors. Twin screw compressors is a type of positive displacement rotary compressors that utilize two intermeshing helical rotors to compress any working fluid. Let's look at the diagram here. We have the external view on the right and sectional view on the left. This clearly shows the main components. The main rotor, also known as the male rotor, is responsible for the primary compression. The gate rotor, or a female rotor, intermeshes with the main rotor to compress the fluid. The bearings, which ensure smooth operation of the rotors. The casing encloses and protects the entire assembly. The suction port is where the working fluid enters into the system. Finally, the discharge port is where the compressed fluid exits from the system. Twin screw compressors offer a high compression ratio and are highly adaptable to varying load conditions. This makes them ideal for handling frequent changes in operational demands reliably and efficiently. Continuing with the topic of twin screw compressors, let's dive deeper into working principle of twin screw compressors. The rotor can be driven either by synchronizing gears or direct drive. As the rotor rotates, the space formed between them and the casing, which is reduced progressively. Thus, the trapped working fluid is progressively compressed along the length of the rotor chamber. Three phases comprises the flow of the compressed working fluid inside these complex geometry machines. In the first step, as shown in the diagram here, the working fluid is introduced through the suction port into the interlobe space between the adjacent lobe of the male and the female rotors. As the rotation proceeds, the gap between the rotors no longer aligns with the suction port. As the rotor rotates, it reduces the space occupied by the trapped working fluid, and this trapped fluid is progressively compressed along the length of the screws. Now space becomes exposed to the discharge port at the other end of the compressor, and through which this compressed working fluid is discharged. Now let's talk about the type of twin screw compressors, which are shown here in the flow diagram at the bottom. Twin screw compressors are actually oil-flooded compressors and oil-free compressors. First, we have oil-flooded compressors, which use oil to seal and lubricate the rotors. This makes them more efficient and helps with cooling during operation. Then we have oil-free compressors, which work without oil. Next are the dry twin screw compressors, which don't use oil or water for lubrication or cooling. We also have refrigerant-flooded compressors, which use refrigerant instead of oil. Lastly, there are water-flooded compressors, which use water for lubrication and cooling. They are more environmentally friendly options in certain situations. Each type has its own purpose and is designed to meet specific industrial needs. Water-injected screw compressors and why we use water in them. These compressors are oil-free, which means they avoid contamination and are perfect for industries where clean air or gas is critical. We use water because it serves multiple purposes. It lubricates, cools, seals, and cleans the system, and eliminating the need for oil. Water is also environmentally friendly, making these compressors a sustainable choice. However, using water comes with its own challenges and it is a low viscosity fluid. This makes the design more complex, requiring advanced engineering to ensure durability and efficiency. The advantages of water-injected twin screw compressors. First one, there is no oil contamination. Since water is used instead of oil, there is no risk of contaminating the compressed working fluid or gas, which makes it ideal for sensitive industries. Second, it also lowers the operating temperatures. Water effectively absorbs heat, resulting in cooler operation and improved efficiencies. The third one, it enhances the energy efficiency. These compressors use less energy due to the combined cooling and lubrication effect of water. The fourth one, it reduces the maintenance costs with no oil filters or oil management systems, which are no more required, and maintenance is simpler and more cost effective. These benefits make water injected compressors a sustainable and efficient choice for modern industries. Offer many advantages, there are significant challenges as well, especially when it comes to the rotors of the compressor. For instance, we have some challenges over here in terms of wear resistant material for the rotors, load bearing capability of the rotors, corrosion, erosion, and moisture resistance of the rotors, tribological properties of the rotors, and clearance stability. These rotors needed to be highly resistant to wear since water does not provide the same protective film as oil, and these rotors must withstand significant mechanical loads while still operating smoothly. Since water is used, the material must resist corrosion, erosion, and the effect of the constant moisture. Friction management and lubrication with water is a complex tribological challenge. These factors require advanced materials selection, precise engineering, and innovative design solutions to ensure reliable performance of the rotors in the compressor. Water lubricated compressors are used in a wide range of industries, particularly where clean and oil-free compressed air is essential. For instance, it can be used in a food and beverage. The compressor provides oil-free air for packaging and processing and ensuring food safety. And they can also be used in pharmaceuticals where they deliver sterile and contamination-free air, which is crucial for manufacturing medicines. They can also be used in electronics manufacturing, textile industry, and other general industries, for instance, energy efficient compressed air supply. Thank you for listening. With that, we conclude today's short lecture. For any further discussion and question, please get in touch.